This is video 4 for atoms and heat. So in this one we're going to start talking by thermal expansion. Why do sidewalks have cracks in them? Why do highways have gaps? Why does glass shatter? So when the atoms in a solid heat up, they gain kinetic energy. That means that their speed increases. And this causes them to push on their neighbor atoms and push their neighbor atoms farther away, causing the material itself to expand. So a long bridge can have its length change by over 2 feet during the course of a year. That's a lot. If you don't plan for that, the bridge can crumble because the concrete can crack, the metal will warp. There's a lot of things that can go wrong with that. So that expansion then weakens the molecular bonds holding the solids together. So heated solids are weaker than colder objects. So, thinking, some rhetorical questions then. How does this knowledge help you to explain the cracks in sidewalks? How could you explain why glass shatters when its temperature changes suddenly? And finally, what should you do when you have a lid that is stuck on your pickle jar? So I'll leave you to ponder these questions. All right, conduction. When two objects are in contact, the touching allows them to share kinetic energy. The zeroth law then implies that the energy will flow from the hotter object to the colder object until they both reach the same temperature. This doesn't happen instantly, and the rate will be different for different materials. Metal conducts heat faster than plastic. So if you pull a hot pizza from an oven, which is safer to touch, the pizza crust or the pizza pan? And if you think about it, both the pan and the crust have the same temperature. They were both just in the same oven. But we all know that you can touch the pizza crust for a little longer than you can touch the metal. The reason why is because metal is a better conductor of heat than the crust is. This also explains why if you're walking barefoot through your house, carpet feels warmer than, let's say, a ceramic floor. They're both the same temperature, but the ceramic floor will conduct heat better than the carpet will. So you're losing more of your heat out of your feet. Yeah, that rhymes. So you're losing more heat from your feet, when you touch the ceramic than you are when you touch the carpet. And that's what makes the ceramic feel colder, even though it's not actually colder. Okay, TNT. Let's talk about what happens when dynamite explodes. So first off, it releases 0.65 calories per gram. And that energy is being turned into heat. The internal kinetic energy will increase by 167. So the temperature becomes 160 times hotter. So, room temperature is 300 Kelvin. So if we do 167 times room temperature, we get that the temperature is 50,000 Kelvin, which is right around 50,000 degrees Celsius. I know there's a 273 in there somewhere, but at these extreme numbers we can round. So at this temperature, 50,000 degrees Celsius, I promise you nothing is a solid. In fact, nothing's a liquid, and it may not even be a gas. It's probably a plasma at that temperature. That is incredibly hot. So then, at room temperatures, um, let's say you have a gram of water and you allow it to evaporate. That gram of steam takes up 1,000 times the volume of a solid of equal mass. So in other words, at room temperature, if you have 1 gram of ice and 1 gram of water vapor, the water vapor will have 1,000 times the volume of that 1 gram of ice. And this goes up with the temperature. So if I took 167 times 1,000, so at 50,000 degrees Celsius, that volume would increase by 160,000 of the solid. So if you had 1 gram of dynamite as a solid, when it turns into a gas, when it explodes, it would have a volume of 167,000, which is a lot. So during an explosion, the dynamite's volume will increase by 167,000. That is a lot. And that leads us into our next topic, which is pressure. So why do heated gases expand? And it helps us to understand the difference between solids and gases. In a solid, the atoms bounce back and forth, but they never leave their relative positions. As the solid's temperature increases, due to heat energy being added to it, the atoms bounce more violently, causing it to expand. The atoms can eventually break free. That's when it melts to become a liquid. The liquid's temperature then can increase from additional heat to where the atoms break free again, and the atoms evaporate to become a gas. So here's a little illustration here between solids, liquids, and gases. At a plasma, the electrons begin to break free from the atoms, and you get like this soup of positive nuclei and negative electrons kind of floating around, and it does some cool things. So when a gas is contained into a box, the atoms bump into each other and the sides of the box. And as the atoms hit the box, they exert small forces on the walls of the box. That's what we call pressure. Pressure is equal to a force divided by an area. So for the ideal gas constant, which is something you probably talked about in chemistry, pressure equals some sort of constant times the temperature in Kelvin. That's the ideal gas law. No gas is ideal, obviously, but it's pretty close. So what makes this law important then, the ideal gas law, is that if you double the absolute temperature, you double the pressure of the gas. So dynamite exploding will raise the temperature around it by a factor of 167. So the gas's pressure will increase by 167 as well. And if we take a look at pressure equals force divided by area, we see that pressure is proportional to force. So if the force increases, or I'm sorry, if the pressure increases, we see that the force it can exert increases as well. And it's by the same factor. So if the pressure increases by 167, the force increases by 167. And that is quite substantial. All right, that will conclude this video.